We're recording. Alright, so if I could zoom in a little bit here, we're doing section 6, topic 8. Section 6, topic 8. And it's called Sketching Graphs of Polynomials. Example 1. Let me move my head out the way a little bit. Sketch the graph of each of the following polynomials. Any idea what, like, while I'm writing, it's not showing as the same speed as, it's like a lag. Right, f of x equals 6x cubed plus 6x squared minus 12x. Okay, and we are going to sketch a graph of this. We know how to do in behavior. Today's one in behavior is going to be really important. Like, why did we learn up, down, 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 up, down? Why did we learn all that? We learned it because when you have to sketch a graph, it's very helpful because it's going to save you some time on the math part of sketching a graph. All right, if you know how to, if you've memorized it correctly. Now, on the test that we're going to have, there are, I think, 4 questions where you have to describe the end behavior. I'm going to give you a polynomial such as I have, and you have to tell me up, up, down, 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 up, down, and it's not multiple choice. If it was, those would be your 4 choices. You still got to know which one it is, right? So if you have not memorized that yet, go ahead and do so now so that you can get those 4 questions right on your test, okay? And there's 4 or 6 questions where, does it look like I'm looking directly at you? Okay, because it's weird for me because I'm just looking into the camera and not at the little square on my screen. So I can't really tell what it looked like. But where you have to name the polynomial based on how many degrees and number of terms, that is also about, I think, 6 questions on your test. So if you haven't memorized those yet, go ahead and memorize those now, okay? Because that's going to be, what, 10 questions out of 18 on your test that are easy, but you got to memorize it.
Memorize what?
In behavior and how to name polynomials based on number of degrees and how many terms they have. Yes.
Are you getting a study guide today?
Not today. We're still learning a lesson.
Okay.
Next class. Okay. So in this example, just before I do any math, I can tell a few things. What's the end behavior?
Down and up.
Down and up.
Down and up.
What would my y-intercept be? 0.
Huh?
It's the constant. Is negative 12 a constant?
Oh, negative 2.
What?
It's negative 2 once you take the GCF out.
No, when you're just looking, when you're graphing, before you're just thinking about factoring. When I'm graphing, just look at the way it's given as long as it's in standard form. The constant 0, right? So the constant always tells me where the graph's going to cross the y-axis. So it's 0. Negative 12x, that's your linear term. Okay? All right, so we know what the end behavior is going to be. We know where it's going to cross the y-axis. Now, to know where it's going to cross the x-axis, we have to solve this. Okay? So we're going to try to solve by factoring to see where it crosses the x-axis, because those are super important points on our graph. So we will solve for x to find where the graph will intersect the y-axis. We will try to solve by factoring. So if we're going to solve by factoring, and I can just set that equal to 0, by the way, but so 0 equals, because where it crosses the x-axis has a y value of 0, right? And f of x is the same thing as y, pretty much. So what's the first question we always ask when we are factoring?
GCF.
Is there a GCF? And give yourself some room over here on the right because we're going to draw a graph over there. Wait, what's our GCF?
6x.
6x. So we're going to factor out a 6x. Should have given myself a little more room. Silly goose, I know. What we're going to divide each term by the GCF.
X squared.
1x squared, or can I just say x squared?
You just say x squared.
X squared
Plus x.
plus x
Minus 2.
minus 2. Boom. Inside parentheses, what kind of polynomial is that?
Quadratic.
Quadratic. Is there a difference of squares?
No.
No. How can we factor a quadratic polynomial?
T-chart divided by.
T-chart divide and slide, right? It's not a sum of cubes. It's not a difference of cubes. It's not factor by grouping. T-chart and divide and slide if it's factorable. Hold on. If it's not factorable, do we know any other way to solve a quadratic?
Perfect cube or
Quadratic formula. Or
perfect cube or squares. Whatever. No, not perfect.
where you create the perfect square,
Yeah.
completing the square.
That, yeah.
Yeah,
That's what I'm
okay.
saying.
So hopefully we can factor. If not, we're going to have to solve a different way. So yes, A is,
1. I already solved the whole thing.
B is,
Oh, B is 1.
and C is
Negative 1.
negative 2. Make our little T-chart. We need two numbers that multiply together to give us A times
2
C.
and negative 1.
Hold on. What is A times C first?
Negative 2.
Negative 2.
1.
And they need to add to give us B, which is positive 1.
Negative 2 and positive 1.
Okay?
Yes.
Negative 2 times positive 1 is negative 2. Negative 2 plus 1 is negative 2. Is that going to work?
No, see, Cody, I told you.
Yes, it is.
This is negative, oh, I meant negative
2
1.
plus 1 is 1. Or negative 1. Oh, it's
Yeah,
positive
negative
one.
one.
Right.
Get positive.
Oh.
So we need no fighting.
Okay, right.
No fighting, boys. It's just math. Positive 2 times negative 1 is negative 2.
You got something right for one.
2 plus negative 1 is positive 1. So now we found the numbers that will work. So come back up here. Remember, we have 0 equals. Don't forget your GCF, 6x. Make 2 sets of parentheses. What's going to be the first term in each set?
X.
And then we look at our t-chart to find the second term. We have a positive 2 and a negative 1. What would I be dividing and sliding by?
Nothing. Because it's
No. It's
But, I mean, if I wanted to, it would be
six.
Are we solving or just back?
1. And is that necessary?
Are we solving or factoring?
We're solving.
Okay, so the answer is positive 1.
Hold on, let me get there first.
It's a lot.
You're answering correctly. You're just jumping to my answer before my questions. You know what I'm saying? Okay. Can we, before we even did any of this, can we just look at the main problem and tell how many solutions we're going to have?
Yes.
We're gonna have.
3. Just by looking at the main problem, not our factors, how do we know we were going to have 3?
Looking at.
Yeah. We have 3 degrees. 3 is our highest degree. That tells us how many solutions we have. Now, we may have some imaginary solutions, but real and imaginary all together, we need 3 of them. If we're missing a solution, well, this will tell you if you're missing a solution. Like, wait, I only have 2, but I'm supposed to have 3 solutions. Something's not right, okay? And remember, your solutions, also known as your roots or your zeros, tell you where the graph crosses the x-axis. So if I have 3 degrees, my graph could possibly cross the x-axis 3 times. If I have imaginary solutions, it won't cross at an imaginary solution. But it can't cross more than 3 times if I only have 3 degrees, okay? So, the reason I point that out is because a lot of people think that the GCF's not going to give them a solution. Well, if that was just 6, does 6 equal 0?
Oh,
No, but it's not. It's 6x. Can I solve for x?
Yes.
What do I do?
Six.
Divide by 6, and x equals 0. Can that be a solution? Yeah.
it's gonna be 0.
Which we already knew that it was going to cross our x-axis at 0 because that was also our y-intercept. That's not always going to be the case. If we set x plus 2 equal to 0, what will our solution be for that one?
-2.
Negative 2, because we'll subtract 2 from both sides. And I am squeezing all this in here because, yeah, I got a graph in. I'm going to have to do more work after that. And then don't forget I had this other factor of x minus 1.
Positive.
It will be positive 1. So do I have 3 solutions? Are they all real solutions? So where's my graph going to cross the x-axis? What's right there?
Good job. -2. All 3 of those answers.
Right, 0, negative 2, and 1. So now that we know where the graph's going to cross the x-axis, let's go ahead over here and sketch our graph. Well, what we know of our graph.
Okay.
I know my x-intercepts, or my roots, or my solutions, or my zeros. It's going to cross the x-axis at 0,
-2.
at negative 2, and positive 1. Now, I'm not going to put anything on my y-axis yet because I don't know how high or low I'm going to need to go. So, I'm going to hold off on that, okay?
Okay.
This is when knowing your end behavior comes in handy because you've got to do a lot less math if you know the end behavior. Our end behavior was down and up. Remember, down, the first word describes the left side of your graph. up, that was the second word, that describes the right side of your graph, okay? So the left side of my graph is going to point down. So go to the 0 that's furthest to the left and just sketch a arrow. Don't make it go straight down, but, you know, in the downward direction. And we know the right side of the graph is going to point up. So go to the 0 to furthest to the right and then sketch a graph pointing up. Not straight up. But do you think my graph starts from the left, comes up to -2, goes straight across, and then once it gets to the 1, it goes up?
No.
No? Something happens between this 0 and this 0. I don't know, does it come down here? Does it go up here? What happens between these two zeros? I don't know. I decay. I have to figure that out. So that's where I'm going to have to do some math, okay? So y'all listen close to me, because this is where kids like, I don't know what number you picked, but right on this part, so listen to me carefully. Once you get to this point, you have to know what, if I have 5 zeros on the x-axis, I've got to find 5, well, I think that would be 4 different ordered pairs. You've got to find an ordered pair in between each 0. Okay, to know how high or how low to sketch the graph. So, if these two zeros, I have 0 and -2. Give me some number between 0 and -2.
-1.
-1, is that the only option?
No.
No. -1.5.
-0.5.
-0.5.
-0.99923.
-0.99923. There's lots of options. Are we always going to pick the same option?
No.
No. Now me, I would just go with -1. Make it easy, okay? So that's what I would choose. If you choose a different ordered pair, your graph may go a little higher or a little lower than mine because you chose a different value for x. It's going to have a different output value, all right? I usually just go right in the middle and use that number. So I'm going to choose -1 to figure out what my graph does between these 2 points. And then I also have to figure out what it does between 0 and 1. Give me an x value between 0 and 1. 0.5, 0.3, 0.1, 0.2, 0.8765431, right? There's all kinds of numbers. Don't make it difficult on yourself. Just choose. I would just go 0.5. So what we're doing is, when I choose -1, I'm going to go back up to my function, and I'm going to find f of -1. So wherever I see an x, I'll substitute in a -1. I will be super careful about my order of operations, and I will say, when x is -1, when I simplify this, that'll give me my corresponding y value. That'll be an ordered pair. I can plot and connect the points. Then I'll do the same thing with positive 0.5, substitute it into my function. Wherever I see an x, I will simplify and find the corresponding y value. And that will give me an ordered pair between 0 and 1. Right on? So that's what I'm going to do at the bottom of my paper. Let's make a little table of values. Now, when I said if you memorize the end behavior, that saves you. If I didn't know the end behavior, I would have to pick a point, an x value to the left of -2, and substitute it into the function to find a y value to tell, is it going up or down? Then I'd have to pick a point to the right of +1 to figure out if it's going up or down over here. But if I just memorize that in behavior, then that's going to save me some math. You know what I mean? So, I'm going to start with -1. And I'm just going to be quiet for this because it's just basic math. But again, because those exponents, be careful of your order of operations. Also, I forgot to say, you could substitute that x value into the standard form like I did, or you could substitute it into the factored form. Usually I do factored. I don't know what I was thinking. This time I did standard form. But they're both equivalent. They're just different forms of each other. So when I substitute in the 0.5 or positive 1/2, I'm going to substitute it into the factored form just to make it a little easier. But you could still substitute it into standard form. That's fine. So you see how I found two ordered pairs? So my first ordered pair that I found was negative 1, 12. So on my y-axis, I will need to go all the way up to positive 12. And the other point was positive 1/2, comma, negative 3 3/4, 3.75. So I'll need to go at least down to negative 3.75, right? That's why I don't like putting like my increments on my y-axis until I know what my numbers are. So now that I do, and your increments have to be the same on the whole y-axis. You can't change them. On the x-axis, they could be increments of 1, and the y-axis, they could be increments of 5. That's fine. But my whole y-axis has to be the same. But I'll just count by ones because it's only up to 12. So when x is negative 1, y is positive 12. So I'll just connect those points and bring it back down to the next 0. The next ordered pair I found was between 0 and 1. So negative 1, negative 2, negative 3, approximately, and just connect those points. Coolio?
Leo.
Coolio. Can you shut that bathroom door, please? He's got it. I don't know why we got so many people up and down back there.
They spilled a drink.
His cup fell and he was picking it up.
That's why we don't have cups like that. All right, shut the door. Sit down. Let's go. Okay, so on this graph, my end behavior is down and up. This would be a relative maximum. It's not my highest point on the graph because I have an arrow that points up to positive infinity, but it is a change in direction. My y values are increasing. They stop and start decreasing, so that's a maximum, okay? We also have a relative minimum right here. My y values are decreasing. They stop and start increasing. We call that a minimum. But, I mean, the graph points in the downward direction to negative infinity. So that's not the lowest point on the graph, but we do call it a minimum. Now, if we looked at this graph on technology, it would look a lot more smoother, obviously. So if I drew back over this, I would make it much more, it would flow a lot better. You know what I mean? But recall that domain is talking about all possible y values. Anybody know what the domain would be for this graph?
Domain would be negative infinity, positive infinity.
Negative infinity to positive infinity. Does that also mean all real numbers?
Yes.
Yeah, you could say it either way, right?
Yes.
Remember, I like to write the cool double R because it's also my initials. If you get confused on that, think about it. Is there any number that if you plugged it in for X or substituted it in for X, could you not simplify and get a Y value? It's not possible, right? You could plug in any number. So your domain's all real numbers. Usually when we graph polynomials, usually it's going to be all real numbers. Okay, your range is all possible Y values. I like to look at my graph for this. So on my graph, when Y is 0, is there going to be a point that has a Y value of 0? 3 of them, actually. Is there going to be a point that has a Y value of positive 1? Positive 2. Positive 3. Positive 12. Positive 13. Why? This point stops right here.
Arrow.
But that arrow, exactly. So am I going to be able to go to positive infinity on my y-axis? Am I going to be able to go to negative infinity on my y-axis? So does my range have any restrictions on it?
No.
Nope, it is also all real numbers. Now I know that my end behavior is down, up. But remember, let's just go back and review how you actually say it, because down, up is not, that's not very math of us. So the left side, we would say, as x approaches what? What are my x values doing as my graph is going to the left?
Negative infinity.
Negative infinity. What are my y values doing as my graph is going to the
Negative
left?
infinity.
Also negative infinity. We also have to describe the right side. On the right side, as x approaches positive infinity, y approaches positive infinity.
Is that always going to be the case with all real numbers?
Usually on the domain, not necessarily on the range. On the range, like if both sides point up, if it's up, up, or down, down, your range is going to have a restriction on it because it's going to have a low point or a high point. But when they go in opposite directions, something's going to positive infinity and something's going to negative infinity. Okay? But if they both are pointing up, then you're going to have a minimum value. Or if they're pointing down, you're going to have a maximum value. And that's going to put a restriction on your range. Okay? Whoops.
Where'd it go?
Where'd it go? Where'd it go? Oh, it's over there. Can't get it. I'm connected. I'll get it later.
Didn't drop.
Cap. Example 2. Thank you so much. That's so sweet. I thought one of the fellows would have done it,
I was
but
going to, but then you said I'll get it later.
she heard me say that too. Yeah, she did. Example 2.
My feet are stuck.
Sketch a graph.
Do you have any homework?
Yep.
Yes?
Whoa,
Yep.
What?
I'm recording this, so can we not do the little, the back and forth possible? I'm back. Did y'all hear that? Turned off the microphone.
Oh.
Okay. What is my end behavior?
Yeah. Up. Down.
Up and down. No, you didn't. You said down and up. Up and down. My degree is odd, so it's opposite directions, up, down, or down, up. If my leading coefficient's negative, it's going to end on a negative note, meaning it's going to point down. So the left side must point up. What is my y-intercept?
Negative 125.
Yeah, are we probably going to use that? Probably not. But if we had to, I mean, we don't have to do increments of 1, right? But that's our y-intercept. Okay. So we need to find out where the graph crosses the x-axis.
Difference.
Still don't know why there's such a delay on there. It's not normally. So instead of y equals negative 8x cubed minus 125, I'm going to put 0 equals negative 8x cubed minus 125 because I want to know when x is what number, y equals 0. Because when y equals 0, that's where my graph will cross the x-axis. So I heard you say something about perfect cubes. Okay,
Difference.
but right now that leading coefficient is negative, so we need to factor that out. Okay? So let's factor out a negative 1. Is there any other greatest common factor? No. So if we take out a negative 1, what do we get?
Positive. Everything is positive.
Everything's positive.
Yeah.
Just changed all the signs, right? So now we have what inside our parentheses?
8x plus 125.
Yes, and to factor that, what is it? Special case, what do we call it?
Uh,
Sum of cubes. And we know to factor a sum of cubes, we have to do the whole thing I taught y'all. Sum of cubes is a plus b times the quantity of a square, what?
oh, a like sum of cubes.
Mm-hmm.
A squared plus 8 minus AB.
Minus ab, because it's a different sign, plus
B squared.
b squared. Mm-hmm. Why did I factor out a negative 1? Because if I'm factoring and the leading coefficient's negative, we always factor it out. Okay. So let's figure out what A is. Remember, A is the cubed root of the first term. Don't look at the original. Look here. So what's the cubed root of 8x cubed? 2x. B is the cubed root of the second term. So the cubed root of 125 is what? 5. A squared, be careful, this is the one we messed up. We found that A was 2x. So 2x, 4x squared. So a lot of kids say, they just say 2x squared or whatever. Remember, that means 2x times 2x, which 2 times 2 is 4, and x times x is x squared. So a squared is 4x squared. Then we have a times b. If a is 2x and b is 5, what's 2x times 5? 10x. And we have b squared. So if b is found to be 5, 5 squared is 25. Y'all got that? So now all we have to do is just take it and substitute it into the formula I gave you, or pattern, whatever you want to call it. So don't forget you have this negative 1 out here. What's a plus b?
Oh.
2x plus 5. And then we have
4x squared minus 10x plus 25.
equals 0. I moved my 0 to the right side. That's okay. I can do that. So how many solutions are we supposed to have according to how many degrees we had? 3 solutions, right? Is my first factor going to give me a solution? Is negative 1 equal to 0?
No.
So we're not going to find a solution there. Can I get a solution from 2x plus 5? Yeah. Solve for x, right? I'll subtract 5 from both sides. Divide by 2. X equals negative 5 halves, or if I'm graphing this, I would probably say negative 2.5. So I know my graph will cross the x-axis